Okay, now that we've seen how to define or create a user-defined function, okay, with a prototype and calling it, now let's look at the advantage of having this function handy. So we can actually call it as many times as we want. So we can go ahead and do this. Greetings. Okay, so again, so you don't have to rewrite code. That's the beauty of having functions. You basically will be executing this line when you call, and you're going to execute that line twice. So if you do it 3 times, again, you're executing this printf statement via these 3 function calls 3 times. So let's see how this works. And as you can see, this is a hello from function greetings, and it did it 3 times. Okay? All right, so remember, you're in control. So within the controlling function, you're going to call these functions. Now let's go ahead and do another example, which means I'm going to create another function here. Let's do it here. So let's write a prototype for it first, void. And let's call this one greetings 2. So names have to be unique. So you can't have the same function name redefined or repurposed. So now let's go ahead and create another function called void greetings 2. Now you can put a number, or you could put anything you want, or the other greetings, but don't start with a number. And we're going to define this one where we're going to printf. This is greetings 2. Hello there. I'll put a /n there and close the curly brace, and let's see how this will work for us. So what we're going to do is, so again, we defined it after main, but we wrote its prototype here. So this is always a good habit. A lot of programmers like to write the function prototypes right here, which means they can tell the compiler what functions they're going to encounter, or the compiler will encounter after main. Okay, so let's go ahead and do greetings 2 here. And that's a function call, so that means now you want to call greetings 2 after you've called greetings 3 times. Now let's see how this works. Compile and run. And there you have it. So this is greetings 2, hello there, right? And it came after these 3 executed. Okay, excellent. So now let's start with another idea where, okay, now we've seen that we can call functions. Can we have them do something for us other than simply print? Can we supply it with a value and then it will print it for us? Okay, so that's the next example that we're going to do here. And let's go ahead and create a new file. And we're going to call this one, let me see what I call the other one. And I'm just going to copy all of this and then delete most of it. So copy, just so I can keep the comments similar. And I'm going to remove my function prototypes that I have here, remove everything here. So I'm gutting my program, remove all my function definitions. And notice now I have a very specific plan as to what can be done. And let's call this one 2. So this will be the file. So function exe2 will be the file .c. So let me just copy this and save it as that. So this will be a .c file. And there you have it. Now, if I compile this, that shouldn't be a problem at all. As you can see, syntax is fine. Now, I would like to pass, listen to this, a value that I declare in main. Let's say I have int a, And let's say I have the user, something like this, printf, enter a value, and then we're going to do scanf, which means we're going to collect this data from the keyboard, right? So %d and %a, so store it there. Now we want a function, watch this, void does not return anything, and we're going to call it print or my print. Okay, my own user-defined function print, and it will take an int. Now notice what I just did here. This is called an informal prototype, which means it will take an integer as a parameter, a single integer. Okay? Now if it were to take two integers, you could put a comma and then an int. If it were to take two integers and a float, then you would do something like this. This is called a signature. Okay? So a function prototype that has data types as a list or a parameter list is called a signature, which means the way this works, it will have, for you to use it, you will have to supply it with two integers and a float in that order. Well, right now we just want an int, a single int, right there. Now you will formally, so this is informal, formal means that int has to be associated to some variables. You'll have to declare the variable within the parentheses. So you're going to rewrite that function since you're defining that function, my print, and now we formally, and let's call it num. That's a formal definition of what the parameter is called. Could I have done num here as well? The answer is absolutely. You could have formally written your signature for the prototype, or you could have informally, by just saying what kind of data type and how many, how many items do you need on the in the list here of this. These are called parameters, by the way. When you add items here, they're called parameters. When you supply it with something, it's called an argument. All right, so we only need one item, but it has to be now formally defined. What is that item called? Now, num, as far as we're concerned, is a local variable. So this num is a local variable to the function myPrint. Okay, so that means we can handle it just like a local variable and print it. So printf, you entered this value. And then we're going to do %d /n and num. Now you're going to say, okay, wait a minute. How is it going to know what to print? We didn't assign any value to num. You assign it when you call. Here's the secret sauce. My print a. Aha. This means you're going to pass a copy of a to num. Notice a and num have to be of the same data type. And since your signature only requires a single integer, you can only have one argument. Okay? So if your parameter has a single item, you can have one argument only. And they have to be of the same data type. What we're doing now is we're passing by what we call by value. It's a copy. So whatever a's value was, you will pass it to num, and hopefully we'll print it for you. All right, well, let's see how that works. Now, some of you might ask, how come you define the function with void in front of it and you don't put void in here? You don't. Unless this myPrint returns something other than void, then we will see that in the next video. Just in case you have that question buzzing in your head. So when it has void in front of it, which means it returns nothing, there is no return statement inside of this function. You simply call it like this. We will see in the next lesson, we're going to look at functions that return values, right? So At this stage, this one accepts a value. It takes a value. So you have to be very clear what kind of value. Here in the signature, you're telling it's going to be an integer. Here, you're formalizing the variable that will hold a copy of that value. And here, you're calling it by supplying it a copy of A as an argument. Okay, so remember parameters and arguments. Let's compile and run this. And notice now we're in main. Remember, your entry point to your program is in main. Okay, so we're going to enter 56. Remember, we're at scanf right now, so I'm going to hit enter. It will execute my print. Let's see what happens when that happens. And you entered this value, 56. So the printing, and this is a custom printing, a user-defined printing function that we created. So we didn't use printf. We used our own myprint, which in itself has printf. But we customized it by calling a function called myprint and supplying it with a copy of the value that's in A. Okay? We're not supplying it A's address. We're supplying it the value that is stored at A's address, which is 56. That's going to be an important thing when we get into pointers later on in a future lesson. And that's when we pass by reference. Right now, we're passing by value. Okay? So it's simply a copy of A being passed to num. Num is a totally independent variable from A. Let me repeat. Num is a totally independent variable from A, but it has to be of the same type. It simply holds a copy of what is stored in A, and that happens when you call myprint and you put A as an argument. You're saying what's in A, give it to num, okay? And num will have that value, and since num is a local variable to myprint, then it will print that result for you when myprint executes. Okay, in the next lesson, we're going to have we're going to use multiple arguments, or the list of parameters will be a little longer than a single one. So it's going to be a little more fun. And then after that, we're going to look at functions that return values, okay? I'll see you then.